we have learned before that Friedel-Crafts alkylation reactions which involve chloropropane, for example, in the presence of aluminum chloride can lead to a mixture of two alkylated products. And what we observed before is that not only propyl benzene was obtained, but also isopropyl benzene. Of course, the key feature of that reaction was carbocation rearrangement, which can lead to another carbocation and therefore another alkylated product. So if it is possible for carbocation rearrangement to take place, then the product or the outcome of the Friedel-Crafts alkylation is always a mixture of two products. Now, what if we want to do this transformation, basically to transform benzene into propyl benzene? But if we want that propyl benzene as the only product, that's really the key quest here, if you like. If we want propyl benzene as the only product, of course, we cannot simply do Friedel-Crafts alkylation employing chloropropane and aluminum chloride, because that will lead not only to the product that's desired here, but also to isopropyl benzene. Specifically, this is what we are talking about. So if you take benzene here, and then you try to do Friedel-Crafts alkylation employing chloropropane. Why chloropropane? Because that's a propyl benzene that's required. If benzene is reacted with chloropropane and aluminum chloride, it's not just that product that would be obtained, but also, of course, as you learned before, it's isopropyl benzene. So not only propyl benzene, but also isopropyl benzene that would be obtained. This is a mixture, of course, a product mixture of propyl benzene and isopropyl benzene. Of course, the reason behind this is carbocation rearrangement, as we learned before. But the question is, if we want that as the only product, so what method or what synthetic route, if you like, we should use in order to get that product and that product only without the isopropyl benzene product? So this suggests, of course, or the answer, of course, we should not do Friedel-Crafts alkylation, because if we do, that's exactly what we get, a mixture of two products. So there has to be another way, therefore, which would improve the reaction, if you like, or which would give us the product that's desired and the only product that is targeted or desired. So the way to do this, or whenever the alkyl group in an alkyl benzene is 3 carbons or more, of course, so when we say longer, of course, we are talking about greater than or equal to 3 carbons. In other words, if the alkyl group or the substituent on benzene consists of 3 carbons or more, Friedel-Crafts alkylation should not be used, because this will give a mixture of two products, but what's desired is only one product. So what's the solution, therefore? Now, the solution actually is a route which consists of 2 steps. So basically a synthetic route that consists of 2 steps. The first step is Friedel-Crafts acylation using an acid chloride that consists of 3 carbons. So propanoyl chloride in the presence of aluminum chloride. This should give the corresponding ketone as expected. This is, of course, Friedel-Crafts acylation. The expected ketone or acyl benzene is actually obtained. What we do next, if you look at this, there are 3 carbons, obviously, but this is a ketone, and of course that's a methylene group in position of the ketone. What can be done here is actually reduction, or specifically hydrogenation. So we can do hydrogenation here. So hydrogen in the presence of palladium on carbon. So hydrogenation reaction should reduce the ketone to the corresponding methylene group. So if you look at this route, it's actually a 2-step sequence, so it is a two-step sequence, if you like, or synthetic route, which employs Friedel-Crafts acylation followed by reduction. Okay, so this is reduction, and of course this is Friedel-Crafts acylation. So acylation followed by reduction is really the way to go here if an alkyl benzene is desired where the alkyl group consists of 3 carbons or more. Yes, it is true. It is a two-step sequence, but the regiochemistry is guaranteed that one product is obtained as desired. If Friedel-Crafts alkylation is attempted, of course, a mixture of 2 alkylated products would be obtained. And of course, that's not good because that's not what's desired in this case. It is only, so that alkyl benzene is desired as the only product. So the solution here is to do 2 steps. Friedel-Crafts acylation followed by reduction to reduce the ketone to the corresponding alkyl group using hydrogen in the presence of palladium on carbon. So a 2-step sequence is the way to go, or the method of choice, in order to synthesize an alkyl benzene where the alkyl group consists of 3 carbons or more.